Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, future engineers, subscribers, viewers, and students. Here is another video on in Engineers in Progress about geometric problems in algebra. I hope that this video can help you improve your thinking skills as engineering students, thereby helping you to become better engineering students and hopefully successful in your chosen engineering course. So for the principle, for a rectangular shape, the area is base times height, BH, or this is the base which is also the length, and H is the altitude also, or the width. Then the perimeter is simply the sum of the sides. There are two B's and two H's. So therefore, the perimeter is 2 times quantity B plus H. Then when the dimensions b and h are equal, then the rectangle is called a square. And for a square, if we denote the side as s, the area becomes s times s, so s square, and the perimeter would be 2 times s plus s, so 2 times 2s, 4s. So that's the case when the rectangle is a square, reduces to a square. Then for triangles, these are the different uh, triangle shapes, but the area is common. It is 1/2 base times height. Because if you notice, if you have a rectangle here, the base is B and the height altitude is H. So if that's why it is just 1/2 of the area of the rectangle. Because if you enclose this shape with a rectangle, the area of the rectangle is base times height, and the total bases for that part and for this part is also b. So that proves that the area of the triangle is only 1/2 of the area of the rectangle. So area equals 1/2 base times height, 1/2 the product of the perpendicular dimensions for these cases here. And for the perimeter, it is sum of the sides, so it is a plus b plus c. Then the sum of the interior angles, the proof is in trigonometry or in plane geometry. All you have to do is draw horizontal line or line parallel to the base here, and the extension of this side forms an angle theta 1, just like that. Then the angle that this side makes with horizontal is theta 3. So therefore, theta 1 plus theta 3 plus theta 2 will form a straight angle, and a straight angle is 180 degrees. So that's why theta 1 plus theta 2 plus theta 3 is equal to 180 degrees or pi radians. So for all cases of this triangle. Then for right triangle, which is this, in addition to the information here, formulas here, the area is still 1/2 base times height, 1/2 the product of the perpendicular dimensions, and the perimeter is in this case b plus h plus c. And for the Pythagoras theorem in trigonometry, we have b squared plus h squared equals c squared. So theta 1 plus theta 2 equals 90 degrees this time, because one angle for a right triangle. That's why it's called right triangle, because one angle is 90 degrees. So therefore, theta 1 plus theta 2 is equal to 90 degrees. And the Pythagoras theorem, b squared plus h squared equals c squared. So next, we have a special case of a triangle, which is an isosceles triangle, wherein two sides are equal. So opposite to these equal sides would be equal angles, also denoted by theta here. So the area is still 1/2 base times height, although in plane trigonometry, there are so many cases for deriving the area of a triangle. So that's the basic, 1/2 base times height. Then the perimeter is B plus 2C of the triangle. And the sum of the interior angles 2 theta plus theta 2 equals 180 degrees. Then you can also apply Pythagoras theorem here. This would be, this altitude will bisect the base. So this is B over 2. This is H. So quantity B over 2 square plus H square equals C square. Not shown here, but I'm just dictating it, mentioning it. You can always apply the Pythagoras theorem whenever a right triangle appears. Then we have a trapezoid. A trapezoid is a quadrilateral with two sides parallel. So for this case, the parallel sides are A and B. So if you imagine, if I draw a line from this corner here to the opposite corner, the area, the shape is divided into two triangles with common altitude h. So for this triangle here on the right side, the base is A and the altitude is h. So from this case here, the area is 1/2 A times h. And for this triangle here, the area is 1/2 BH. Therefore, the area of a trapezoid is 1/2 quantity A plus B times h. And if we are going to interpret this, it is area of this triangle part 1/2 A the base times h, and the area of this part here is 1/2 B times h. So it is just 1/2 quantity A plus B times h. For you to easily recall it, it is also interpreted as the average of the lengths of the parallel sides or parallel bases. That's the average or the mean times the altitude h. So this average 1/2 A plus B is a line segment joining the non-parallel sides and joining the midpoints of the non-parallel sides. So the length of that would be average of A and B, which is interpreted by this. I'm not showing it here, but the definition of the median 1/2 quantity A plus B is a line segment through the midpoints of these non-parallel sides. So that line segment will also be parallel to these two parallel sides. So take note of that. Then for the perimeter, it is the sum of the sides. So A plus B plus C plus D. Then for the sum of the interior angles, since there are two non-overlapping triangles that can be drawn, so either in that manner or in this manner here, we can always draw two non-overlapping triangles. Since the sum of the interior angles of a triangle is 180 degrees, and since there are two non-overlapping triangles that can be drawn here, then the sum of the interior angles of a trapezoid therefore is 2 times 180, so it is 360 degrees. Then for any closed polygon in general, the number of non-overlapping triangles that can be drawn is n minus 2. So for instance, in this quadrilateral here, there are four sides, 4 minus 2, so 2. 2 times 180 degrees. So for closed plane polygons, convex polygons, then the sum of the interior angles can be derived also in plane geometry or in trigonometry as number of non-overlapping triangles times the sum of the interior angles of non-overlapping triangles. In this case, if there are 5, but this is in general, we can form 3 non-overlapping triangles. This is the first, this is the second, and that's the third. So 3 if there are 5 sides in particular. In 4 sides, like this quadrilateral, there are 2 non-overlapping triangles. That's why 2 times 180 is 360. If there are 5 sides, then the sum of the interior angles is 5 minus 2, so 3 times 180, so 540 degrees. So in general, the sum of the interior angles would be quantity n minus 2 times 180 degrees, and that's the general formula for the sum of the interior angles. For the perimeter, it is just the sum of the sides. And for the area, we will gain techniques in plane geometry later by mastering the area of one triangle. So it is simply the sum of the areas of individual triangles. That's the general case here, but from algebra's point of view, we just limit our focus to common shapes such as rectangles, squares, and triangles. The most would be that of trapezoids. So perimeter is sum of sides in general. So let's have now our first example. A rope 75 feet long is cut into two pieces where one is 11 feet longer than the other. So find their lengths. So if we will call the shorter part of the rope as S, then the other part would be S plus 11 because the other piece is 11 feet longer than the other. So S plus quantity S plus 11 equals 75. 2S equals 75 minus 11, 64. So S is 64 over 2, so 32 feet. So if the shorter part is 32 feet, the longer part would be 32 plus 11 or 75 minus 32. So that is 43 feet. 32 plus 11 is 43 feet. 75 minus 32 is also 43 feet. So the longer part is 43 feet. Problem 2. An 18-foot post breaks at a certain point but still connected at the breaking point. The other end of the post reaches horizontally a distance of 12 feet from the base of the post. How far is the breaking point above the flat ground? So we can use Pythagoras theorem here. You may draw the figure if you want. So this is, imagine this is the vertical post. So if it should be vertical, 18 feet high. Then the breaking point above the ground, we will call that X. Then it breaks, so it will fall like that. It will form a right triangle. The longer segment would be the hypotenuse of the right triangle, and it is 18 minus X because we call the height of the breaking point above the flat ground as X. So this would be 18 minus X, the hypotenuse, and this horizontal distance would be 12 feet. Therefore, X squared plus 12 square equals this side 18 minus X quantity square. So X square plus 12 square equals quantity 18 minus X square. Expanding the right side, so X squared plus 144 equals 324 minus 36X plus X squared. Remember, the middle term is twice the product of 18 and negative X. So cancel out X squared, transpose negative 36X to the left, so 36X equals 324 minus 144, and that is 180. So 36X equals 180. X therefore is 180 over 36, so it is 5 feet. So that's why the hypotenuse is 18 minus 5, so 13 feet, 5 feet, 12 feet. Remember the relationship by Pythagoras theorem. 12, the perpendicular sides, 5 and 12, and the hypotenuse would be 13. 5, 12, 13. So familiar that proportions of sides for a right triangle. Problem 3. Find the dimensions of a rectangle where the altitude is 4/7 of the base and the perimeter is 330 feet. So perimeter is quantity is 2 times quantity b plus h. So the perimeter is 330 equals 2 times quantity b plus 4 over 7 of b, because it is mentioned here the altitude h is 4/7 of the base, so 4/7 of base. 330 over 2 is 165 equals 11b over 7. The simplification of this is 7b plus 4b, 11b over 7. So solving for b, 165 times 7 over 11, so b is equal to 105 feet. and the altitude is 4 over 7 of 105, and 4 over 7 of 105 is equal to 60 feet. Problem 4. One dimension of a rectangle is 4/5 of the other. Find the dimensions if the perimeter of the rectangle becomes 62 feet when each dimension is increased by 2 feet. So first, the altitude or the other dimension is 4/5 of the length or the base. So perimeter is 2 times b plus h. Substitute 62 equals 2 times quantity b plus 2. 62 equals 2 times the base is increased by 2. The altitude is also increased by 2. So 62 over 2, 31 equals b plus h plus 4. So b plus h, where h is 4/5 of b, is 31 minus 4, 27. So we replace h by 4/5 of b, solving for b. B is equal to 5b plus 4b is 9/5 b. So b is 27 times 5 over 9, and it is 15 feet. So, and altitude h is 4/5 of 15. So it is equal to 4 times 3, so 12 feet. Problem 5. The length of a rectangular lot is 3 times its width. If the length is increased by 5 feet and the width is decreased by 2 feet, the area of the lot decreased by 21 square feet. So find the dimensions of the rectangle. So area base times height, and the base is 3 times the altitude h. So replacing b by 3h, so original area is 3h square. So when we increase the base by 3 feet and the width decreased by 2 feet, then the area is decreased by 21 square feet. So the base is 3h, take note. Let's increase that by 5, 3h plus 5. And the altitude is decreased by 2, so h minus 2. And we equate this to the original area minus 21 because it is mentioned here the area will decrease by 21 square feet. So the original area is 3h square, so equate it to 3h square, then minus 21. Expand the left side, so we have 3h square minus 6h plus 5h. So 3h square minus h, then 5 times negative 2, negative 10. Then in the right side, 3h square minus 21. So simplifying and expanding the left side, 3h square minus h minus 10 equals 3h square minus 21. So cancel out 3h square, transpose negative h to the right, negative 10 plus 21 is 11. So 11 equals h, 11 feet equals h, then the base is 3 times 11, so 33 feet. Problem 6. Find the angles of a triangle where the smallest angle is 36 degrees smaller than the next larger angle, and the largest angle is 111 degrees larger than the smallest angle. So if we denote the smallest angle as S, then the next larger angle would be S plus 36 degrees. And the largest angle is S plus 111 degrees. And the sum of these interior angles is 180 degrees. Therefore, S plus quantity S plus 36 degrees plus quantity S plus 111 degrees equals 180 degrees. S plus S plus S is 3S, 180 degrees minus 111 degrees minus 36 degrees is 33 degrees. So 3S equals 33 degrees. Therefore, the smallest angle is 11 degrees, 33 degrees over 3. The next larger angle is 11 plus 36, so 47 degrees. And the largest angle is S11 plus 111, 122 degrees. So that's it for that problem 6. Problem 7, this is the last for this video. A wire 60 centimeters long is bent into the form of a rectangle such that the length of the base is 18 centimeters. If the wire is reshaped into the form of a square, find the increase in area. So when the rectangle is reshaped into a square, the area will increase. So take note of that, because the square, for rectangular shape, the square will have you will use the smallest, shortest perimeter to enclose a given area, fixed area. So that's why you will learn this in calculus, that the the shape of a region, rectangular region, that will enclose greatest area as long as it is rectangular is a square. But in general, given the fencing material, the shape of the area that will be maximum enclosed by a given length of wire would be circular, and you will also learn that in calculus. So in this case, let's just uh, solve this problem. 60 is the perimeter, and it is 2 times quantity b plus h, where b is 18. So 60 equals 2 times b plus h, so 30, 60 over to 30 equals 18 plus h. So that means h is 12, 30 minus 18. So the area originally of the rectangle is 18 times 12, and that is equal to 216 centimeters square. Then when it is reshaped into a square, the perimeter is 4 times s, and it is equal to 60. So that means the side of the square would be 15 cm, and the area of the square is 15 square, which is 225 square centimeters, greater than 216. So the increase in area is 225 minus 216, and that is equal to 9 square centimeters. So that's it for this video. I hope that you learned something from this video, and your thinking skills will develop. Although problems here would be light, but it will really help improve your thinking skill later.